Hi guys. This is well, it's not really notes, it's just some practice problems, some example problems to look at for the arc length and sector application um, worksheet and iLearn. Then we're actually going to go over two of the iLearn questions. So I'll do the three guided practice problems that are on the worksheet, um, and then two of the iLearn questions we'll go through. All right, so number one here says draw a circle with a radius of 8 units and a sector formed by a central angle of 30 degrees. Find the arc length and area of the sector, round to the nearest tenth. So this is kind of just a review question. So let me zoom in on this a little bit. Okay, so if we draw a circle, okay, there's a central angle of 30 degrees. Okay, and a radius of 8 units. All right, and we want to find the arc length, so that's this distance here. So our arc length formula was x over 360, which is the part of the circle we're looking at, times the circumference, which is 2 pi r. So our arc length here is going to be 30 over 360 times 2 times pi times a radius of 8. Okay, and they want us to round to the nearest tenth. So if we go over to our calculator, we have 30 divided by 360 times 2 times pi, and then times our radius of 8. Okay, and that's going to give us 4.2. So round to the nearest tenth, that's one decimal place, so 4.2. So our arc length here, arc length equals 4.2 units. Okay. Right, and then they want us to find the sector area. So that's this area here. Right, so again, sector area is going to equal the portion of the circle we're looking at, x over 360, right, times the area of the whole circle, which is pi r squared. So instead of finding the area of the whole thing, we're just going to find this portion. The portion we're looking at was 30 over 60. 30 over 360 times pi, and then your radius was 8. So 8 squared. So if we put that all in the calculator, again, we have 30 divided by 360, which is a 12th. And then times pi, and then times our radius squared. Right? Yeah. Okay, we had equals, round in there's tenth, so that's one decimal, so 16.75, so that's going to be 16.8 units squared. Units squared. It's 16.8 units squared. All right, so let's kind of review from last week. Okay, and then we have another one. This is the first year Janice is playing softball. She has been practicing her batting. On her last swing, the bat made an arc with a radius of 48 inches and swept through 225 degrees of rotation. All right, so if she's batting, let's see, oops. Let's see if I can't draw. Okay, so she swings a baseball bat. All right, 200 and try to draw a bigger swing rotation. right? Let's say she swings it all the way around here, right? And then it's over her shoulder the other way, right? So that swing arc is 255 degrees. Okay, the bat itself is 48 inches, so that's your radius. Okay, and she swung it 225 degrees around. Assuming the arc is circular, what is the distance where the tip of the bat travels to the nearest inch? So we're looking for the arc length of this 255 degree arc. Okay, so we're looking for arc length with it, which is x over 360 times 2 pi r. Right, so arc length, we're looking at 255 degrees out of 360. Okay, times 2 times pi, and the radius here is 48. Okay, so arc length, right, and then we put that in the calculator. 255 divided by 360 times 2 times pi, and then times the radius, which was 48 inches, okay, which is going to be 213.6 inches. Okay. To the nearest inch. So that's 214 inches, right? We round it to 214 inches. Okay, and then we want how many feet this is round to the nearest foot. So to go from inches to feet, we got to do our stoichiometry. There are 12 inches in a foot. In 1 foot. So our inches are canceled, and we have to do 214 divided by times 1 divided by 12. So we got to do our answer times 1, which is the same thing, right? And then divide by 12, because there's 12 inches in a foot. That's going to be 17.8 feet. All right, so $17.8 feet, or 214 inches. All right, that's the length the tip of the bat travels when Janice swings. Okay, at Mickey's mechanic shop, a pulley system is used to lift engines from cars. The pulley system consists of a cable that goes around a pulley with a radius of 1 foot. To the nearest degree, how many degrees of rotation are required for an engine to be lifted 10 feet? So we have a pulley system. So here's the pulley. Okay, and the cord is wrapped around it, right? And then it comes down to an engine, right? So here's an engine down here. Okay, we want to lift the engine up 10 feet. Okay, and then the radius the radius of the pulley is 1 foot. All right, so what we want to do is we want to figure out how many times we have to rotate this to pull it up 10 feet. So first off, we need to figure out what our circumference is. Right, so our circumference is 2 pi r. So our circumference is 2 times pi times 1, which is 1. So our circumference is 2 pi feet. Okay. So every time we rotate this, right, we're going to go up. It's going to get pulled up 2 pi feet. Right, we probably want to get a number for that. So let me do that in the calculator. 2 times pi is going to be 6.28 something. So let's just call it 6.28. right? So if we use our arc length formula, because basically we're going to be using the arc length formula here. So arc length is going to equal basically the what we're looking for, how many times to the nearest degree we need to rotate it, right? And then times our 2 pi r. So basically we're looking for an arc length of 10 feet. And then x over 360. And then we know our circumference here is 2 pi r, which we already solved for, was 6.28. All right, so the reason it's 10 feet is because when you're engaging the pulley, the wire that's holding up or whatever is pulling up the engine that goes around the pulley, the cable, right, is getting wrapped around the pulley. And so if the pulley has a radius of 1 foot, we know it has a circumference of 6.28 feet. So when you wrap it around the pulley one time, it's going to go up 6.28 feet. All right. So again, we have to do inverse here. So you need to multiply both sides by 360. Right, and then divide both sides by 6.28. Whoops. 6.28. All right, so those cancel on this side, and that cancels. And you have 360 times 10 divided by 6.28. That's going to be 573.2. Right, and then if you divide that by 360, you can figure out how many times you had to pull it around, right? Because 360 is 1 turn. 720 would be 2 turns, so you really have to do it just over 1.5 times. You have to crank it all the way around 1.5 times, and that'll pull up the engine 10 feet. Okay, but that's going to be our rotation required. We're going to need to rotate that pulley 573 degrees, which is a little over 1.5 times to pull up 10 feet, to wrap 10 feet of coil or 10 feet of cable around our pulley. Okay, so those are the 3 guided questions there. We'll do obviously a walkthrough video as well for the practice problems.